Hello everybody and welcome to today's Unity ECS tutorial video where we're going to be talking about animation curves. Animation curves, that's what we're talking about. It's not what you wanted, but it's what you're going to get. Only kidding. Animation curves are actually extremely useful for game development. You see this most often used if you want to, ease into some sort of motion. Maybe you don't want your character to just start from zero and then as soon as the player hits the, input key, they're going to be going full speed immediately. Sometimes you kind of want to ramp that speed up a little bit so it feels a little bit more natural. So that's definitely a good use case for these animation curves. Now, unfortunately, when it comes to Unity's entity component system, we can't necessarily use these animation curves right out of the box because these are all reference types. So basically in today's video, I'm going to be showing you a way that we can kind of work around things a little bit so we can create, basically the same effect of an animation curve and have it fully compatible with Unity ECS. So that is what we're going to be talking about in today's video. But before we get started, let me just do a quick overview on animation curves just so we can kind of get everybody up to speed. I'm sure you've probably seen these in the editor before. It's like that little gray box with that green line running through it. And then if you click on that, you can actually edit that green line. And that's basically how we can configure our animation curve. Now, generally, we're going to traverse this graph from left to right, with the left side looking at the x-axis. That's going to be 0. They call this the basically time value. So you can say this is 0 time on the left. And then over on the right, that's going to be a value of 1 time. So it's just a 0 to 1 as far as time on the x-axis. And then on the y-axis is essentially our output value, which also goes from a value of 0 at the bottom to a value of 1 at the top. Basically, the way this works is we put in a value on the x-axis and it's going to look up, where that is on the animation curve and then give us that y value as our output. Generally, again, we're going to be doing this over time. So we start, from the left, and then over time, we can kind of, ramp that motion up or just, traverse that animation curve however we see fit for our project. And the thing about these animation curves is that every X value only has exactly one Y value as output. So the animation curves can't go back on itself or anything like that. So anyways, I've created this simple little animation curve display to show us kind of the theory behind how we can get this to work in Unity's entity component system. And I built out this little visualization just right in Unity using the shapes asset off the Unity asset store. I will leave some links down in the description to purchase this asset if you like. I do think it is a really great asset. So anyways, we just have this really simple animation curve right here, just kind of a nice ease in. So basically, this is a lot of times is used for smooth motion if you want to have something kind of start out slow and then over time it speeds up quicker and quicker and quicker. So again, we can't just use this animation curve in ECS right out of the box. We're going to have to do, a little bit of conversion to kind of convert it into a pseudo value type, if you will, where we basically just store an array of points and then we can use those to kind of calculate, where we would be on this particular animation curve. So basically what we're going to do is we're just going to plot out a few points on our graph here. So you can see we'll just start with the very first one and the very last one. Now, unfortunately, this isn't really going to do a lot for us, so we kind of need to break up this animation curve into sections. So here I've just gone ahead and evenly split up this curve using 4 different points. So see the first one at the bottom, the next one here, the next one here, and then the last one up at the top. So now what we're going to do is put all these points into an array, starting with index 0, the next point will be index 1, the next will be index 2, and the last will be index 3. So now that we have our array, we can just sample, any given point. So I want this at this time value, what is the result that I'm getting? Same thing for this one here. If we put in this as input, we can get our output super easy. It's just accessing data from an array. Now where things get a little bit more interesting is what happens when we pass in the value in the middle in between these. Well, we don't have this particular point right here saved. So how exactly do we handle this? Well, there's actually 2 ways that we can do this. So one easy way would just be to sample the previous point and then use the value as that. Now you can see that this little purple dot, this represents our output, what we're getting out right here. And it is a little bit a ways from the green line, which is the actual animation curve. And as you can see, it starts off, it's fairly close, but then it gets a little bit further away. Of course, it's going to jump right up to the next point, and then we're going to get further and further away. And then same thing with this next step here. So that's not necessarily the ideal situation that we want to have. So what we can actually do is do a linear interpolation between the y values of the previous point and the next point, and that will give us a little bit better of an approximation of where it would be. And as you can see, when we go from side to side, it is kind of following that animation curve a little bit better, but there are some points where it does kind of stray away, particularly right in the middle of the 2 points. So now let's go ahead and increase the sample points up to a value of 16. You'll see that, as we store more points, we do get much more accurate and much closer to the exact, position of the animation curve as we want it to. Now you can see that there is a little bit of that green line kind of peeking out behind the red. The red basically represents what we're going to be able to calculate on the ECS side, and the green represents kind of the true position on the animation curve, if you will. Now I'd say for something like this would probably be pretty good enough, especially if you're just using this for like a quick, like ramp up in speed. It's going to go through this curve in like half a second, and you don't necessarily need to be like super accurate. However, what if we change up our animation curve so it's, a little bit more crazy? There's kind of a lot more going on. We have a lot more of these kind of peaks and valleys. Well, as you can see, we're not getting quite up to the peak of this one right here. And, where it would be at its peak, it's already coming back down, down to the next point. It doesn't quite hit the valley and the peak and the valley on there. As this one is a little bit of a slower part of the curve, so it's a little bit closer, but then again, we get kind of like way off in this particular curve right here, so that's just, really not what we want. So as you kind of increase the complexity in your graph, you are going to need to increase the amount of sample points that you have. This is how it looks with 32 points. You can see it's a little bit better, but some of kind of the extreme edges, we're still missing some. We go ahead and double this and turn off the points here, and you can see, this is like pretty close. Like I'd be pretty comfortable with using this in a game, but you can see that there are still some points where it's just, a little bit off. And if you really need that high level of accuracy, maybe we can just go ahead and double the amount of points again. As you can see, that's, pretty much identical to what that curve is going to be. However, at this point, we're saving 128 positions, so that's going to be, a little bit more memory costly than just saving like 16 points on a curve. So now, as you can see, this data can potentially add up pretty quickly here. So for that reason, I'm basically choosing to store all this data in a blob asset, so that way we can have multiple entities reference the same bit of data without having to store all this data on the entity, and then we're just taking up a bunch of space on each entity. And more often than not, if we have like a bunch of entities who have pretty similar behavior, they're most likely all going to be referencing the same animation curve anyhow. So it really just makes sense to store it as a blob asset so we can really reference that from anywhere. Now, if you are unfamiliar with blob assets, I've done a few videos on this channel kind of going over what they are and how to use them. They are extremely useful tool for Unity ECS. We can store immutable data and reference it from any entity in our game. Now, there are a little bit of performance trade-offs on that, but I do think that for something like this, it makes sense to use it. All right, so here's just a quick overview on the sample project that I'll be building out today. And as per usual, I'll have links to the project files as well as code featured in today's video down in the description below. So now basically, I just have this little capsule entity here. When we hold down the W key, it's going to kind of slowly ramp up and then go up to its full speed. When we let go, it's going to stop moving, and then it's going to kind of, reset the animation curve. So basically we're going to be starting over from 0. Again, when we start going again, it's going to slowly ramp up to its full speed. So pretty simple demo. If we just go ahead and look at the player, all we have on it right here is this acceleration timer, which basically allows us to kind of figure out, where we are in this particular animation curve. And we also have a base move speed. So this is set to a value of 10. Now the base move speed is essentially its, like target move speed, if you will, that we're going to be ramping up to. Now for the actual acceleration curve itself, I've gone ahead and put this on a game controller. The reason I did is because I wanted this on like a central object that we're actually, can create this acceleration curve on. And then, if we have a bunch of different entities that want to reference the same acceleration curve, we can just first go to the game controller and then get the blob asset reference from that. Now, again, in this case, I've just used a simple central game controller, but maybe if you have some like enemy spawners or something like that, you can probably hold that on there. And then, when that entity is spawned, you can just drop on the, particular blob asset reference or references that it needs to, reference. So here you'll see that I have the animation curve. If we pop this open, you'll see that we're just kind of doing an ease in, ramping up this here. And then also a value for number of samples, which is set to 16. Okay, so here we're going to jump over to our code editor, and we're going to first start by creating a public struct, which I've called sample curve. Now this sample curve basically is going to store, all the data associated with our animation curves. Now this is a struct that we can actually reuse if we're using maybe a bunch of different animation curves. So maybe we have like an acceleration curve and a deceleration curve and some other movement type curves. We can always use this base sampled curve struct to hold our data. So first I'm going to create a public blob array of type float, which I've called sampled points. And this basically is going to be our array of points. And again, this array is going to be indexed by point from left to right. And then the actual value stored in there is the Y value at that given point. And then also we have a public integer for the number of samples. This basically means, how many times we're actually splitting up our graph, so we can kind of have some control over the accuracy of our blob curve. Of course, the higher the number, the more accurate it's going to be. Next, we need to create our blob asset reference. Now, this is the actual I component data that's going to be associated with an entity that we want to reference a particular animation curve. So in this case, I've called this the acceleration curve reference. Now, the reason I did this is because we want to be using this blob asset reference specifically with acceleration curves. Now, of course, entities cannot have multiple of the same component type. So for example, if we wanted an acceleration curve and a separate deceleration curve, we would need to have different blob asset references, one for the acceleration curve and one for the deceleration curve. So basically, every single type of curve that you have is going to need its own blob asset reference. And you see I've just created this public blob asset reference of type sampled curve, which is our underlying data struct, and I've just called it value. All right, so next up is the acceleration curve authoring script. Now this is what actually sits on the game controller game object. And this is what allows us to actually set the animation curve for our acceleration and then set the number of samples that we want on it. So this is actually what we're interfacing with in the editor. And then when we actually go to run our game and that game object gets converted to an entity, then the steps inside this convert method here, we're actually going to go ahead and build our blob asset, and then we can create our blob asset reference, and then we'll just sit that on the game controller for now. So I'm not going to go really into details about how I'm setting this blob asset up and the blob asset reference, but do go check out the video that I made on blob assets to learn a little bit more about, what exactly is going on here. But you can see basically what we're going to be doing is we're just going to be allocating an array here. And then here inside this for loop, this is where we're actually going to populate this. Now this is the part that's going to be unique to animation curves specifically. So basically I have this for loop that's going to start at 0 and go up until the number of samples is reached. So first we can just create a var sample point, and we can do index divided by number of samples minus 1. Now, by the way, I do need to cast this to a float here. Otherwise it would just return an integer. So basically what we're doing with this step is figuring out how to evenly distribute these points across the x-axis. Now, just by doing this simple little math operation, we can basically calculate, where a given index would be on the x-axis, again, from 0 to 1, 0 being the left and 1 being the right. Now, using this sample point, we can get the sample value, which is going to be the y value at that given point that we're looking at, just by going to our acceleration curve and doing a dot evaluate, passing in our sample point. And then finally, all we need to do is just go to our sample curve array at index I and set that equal to our sample value. Of course, we're just going to loop through this for the number of times that we're going to sample it. And then we have our array fully populated with all the data. So now that we actually have our data, the next step is to actually access this and use it in our game. So just going to give you a little bit of extra context about how this is set up. You'll see that I do have this base move speed here, and this is just a fixed value for essentially its maximum speed that it's going to. And again, we don't want our player to just go immediately to that full speed. We want it to kind of ramp up to that speed. All right, so next up is the acceleration timer. Now, basically, this is going to keep track of kind of where we are on that animation curve on the x-axis from left to right, so that we can kind of use that to calculate the output at any given position. So really, I'm only storing two float values in here. We just have a value and a max. So basically, the way this works is we're going to put in a value for max. We'll say 5. So that's going to represent 5 seconds. So that means it's going to take 5 seconds for us to go from 0 to 1 on our graph. Basically, from the time that we start moving, we want it to take 5 seconds to ramp up to the top. And then the value is basically a timer of where we are. So the frame that we start moving, we're going to start immediately counting up this value from 0, and it's going to count all the way up to a maximum value of 5. You can see I've set up this operator and this increment function to basically just kind of increment that and just make it a little bit cleaner. And then the two other things I have, one is a public property called normalized, which basically just does value divided by max, because again, our animation curves run on a time from 0 to 1, but if we're actually running on a different time than 0 to 1 second, so for example, again, it's from 0 to 5 seconds, we need to do a little normalization to basically make that 0 to 5 a function of 0 to 1. And then finally, I just have a little helper function to reset the value to 0. Here, I just wanted to point out this system. This basically runs on anything that has an acceleration timer, but it does not yet have its acceleration curve reference. Basically, all it's going to do is it's going to look at that central game controller. It's going to get the acceleration curve reference off of it, and then it's going to go ahead and add that to our entity and then set the data value on it as well. And so that's how our player entity gets the acceleration curve from the central game controller. Okay, so now here is finally actually where we are using and accessing this data through code. Now, basically, you'll see that I've structured this entities.forEach function. I'm looking for anything with read and write access, of course, to the translation, because we're going to be moving the translation. We also need read and write access to our acceleration timer, so we can increment that acceleration timer over time and use that to see where we should be at on our animation curve. Next, we're going to need read-only access to our acceleration curve. Again, it's a blob asset, so all the data is immutable, means we can't edit it anyways. But really, we're just using this data as a way to reference where we would be on an animation curve. And then finally, we also have read-only access to this base move speed here. So you see, basically the way this works is when we press the W key and we want to go forward, we're just going to go ahead and increment that acceleration timer by delta time. Again, I can just do this plus equals because I've set up the plus operator on this particular data component. So that's just kind of a custom thing that I built in because it's a lot cleaner to do it that way. And then here I'm basically just defining a variable for the acceleration modifier. You'll see that basically the way this works is we're going to be modifying our translation.value, just doing a plus equals on the math.forward. So we're going in the forward direction, multiplying that by our base move speed, multiplied by the acceleration modifier, multiplied by delta time. So a lot of multiplications going on, but basically that's how we can kind of calculate the end value of what it needs to be. Now, I know I kind of skipped over how we actually get this acceleration modifier. Reason is because it's a little bit messy, but basically I'm going to be showing you the solution that I did to make it a little bit more cleaner here. So you'll see that I'm just doing an acceleration curve.get value at time. And then here we're passing in our acceleration timer.normalized. Again, we do need to pass in that timer value normalized from 0 to 1. So basically, let's go back to the very first script that we had open, the sampled curved struct. So this is basically, just a little helper function that I've added on here, which is the get value at time. So we just pass in a float for time. And then here's where we actually do our calculations that I was kind of talking about at the beginning of the video. So the first thing that we're going to do is get our approximate sample index. So basically, based off of the time and the number of samples that we have, we can approximate, what this index would be. Now, this is going to be returned as a float. So for example, if we were right in between, index 7 and index 8, we would get a value of 7.5 for this. Next, we need to get the sample index below. So we're just doing a simple math.floor, passing in our approximate sample index. So basically, if we're in between two sampled points, we're going to go to the previous sampled point and then kind of use that as a base here. This is just a quick check if we're at the very exact last point, but other ways we can skip that. However, if that's not the case, if it's anywhere on the graph, we're going to need to calculate essentially what I've called this index remainder. So again, if we're between the values of say 7 and 8, again, we're sampling at say 7.5, well, the index remainder is going to be the difference between the point that we're trying to sample at and our actual previous point. So in this case, it's going to be a value of 0.5. Now, the reason we do this is because when we're linearly interpolating between points 7 and 8, we need to know, how far from one side or the other are we on in order to get the correct value. So again, in that case that I mentioned, we're going to have a value of 0.5. So we can just do a simple linear interpolation between the value that we have at 0.7 and the value that we have at 0.8. If we just kind of go right in the middle of those, we have our value. And so you can see that's exactly what I'm doing here. We'll just go ahead and return math.lerp, sampled points at index below, sampled points at index below +1, and then use the index remainder as our t value for the lerp function. Now, one way to make this even cleaner still is we'll just go on to our acceleration curve reference I've created this public read-only float get value at time. Again, we're going to pass in the time value, and this just returns value.value.getValue at time, passing in time. So this just kind of saves us writing this value.value a couple extra times over here in our system. So again, you can just see that we're doing this acceleration curve.getValue at time. Again, this acceleration curve is that blob asset reference, the acceleration curve reference. So again, we can just call our get value at time, passing in our normalized time right there. So, are we having fun yet? We'll come back over to Unity. We'll just take a look at our animation curve. Again, we're just kind of ramping up to full speed here. Looking at the player again, we do just have this acceleration timer. The default value is going to be 0, and the max value is 5. And we also have a base move speed of 10. So for example, you just enter play mode and let me hold down the W key and you'll see that it's going to start very slow and then it's going to finally over time, over 5 seconds, ramp up to its full speed right there. And I'll do this again. We'll see that, as we hold it down, have it go, it's going to ramp up a little bit. And if I let go, it's going to reset that timer. So the next time I press the W key, it's again going to start off from that slow crawl and then continue to ramp up to full speed there. Of course, we can come in and really tweak with these values. So let's say, maybe we're going to ramp up over 0.5 seconds. So we'll go ahead and hit play, and then you can see that it ramps up to full speed, very quickly. Or we can say play around with this. So it's going to ramp up a lot quicker and then kind of smooth out over time here. Just go to our player and change this to say a value of 2 seconds, just so we can kind of see that. And then we see that it starts off a little bit quicker and then just, continues over and on. I don't know. So anyways, that is an overview about how to add animation curves to our Unity ECS project. Again, I do think these animation curves are a really great feature of the Unity game engine, just so we can make things look a lot more smooth and less mechanical, and they have plenty of applications all over. And while this may not be the most ideal situation, and it does feel like kind of a workaround that we have to do to get these implemented, I do think that this is pretty good for most use cases. But anyways, I would love to hear what you think. Let me know if this is something that you plan on using in your project moving forward, or if you came up with a different solution for this on your own. Really would be interested in hearing what you have to say. Anyways, do hope you enjoyed today's video and you found it helpful. If you did, I'd really appreciate it if you hit that like button. Also, feel free to subscribe to the channel for lots more videos about Unity's entity component system and their data-oriented technology stack. Of course, if you do have any questions for me or suggestions for future videos, you can always leave those down in the comment section below, or join us over on Discord over at tmg.dev/discord. I hope you all have a fantastic rest of your day, and I'll see you in the next one.